Hello everyone. So in this particular video, we'll be talking about your roadmap with respect to computer vision in machine learning or deep learning or in general data science. Okay, so how you should approach the domain of computer vision in these data science domain. Okay, so there are 9 steps that I have, or basically 8 steps. So the ninth one is more of a summary, but or let's say way forward. So let's get started. So the first thing that you need to do is now I assume you already have experience in Python, so you already know coding and you also know some amount of mathematics. Okay, so these two things are assumed because if you are doing computer vision, I assume you already know programming and basics. Okay, so here what you can do is you need to first start with something called as OpenCV. Okay, so OpenCV is your computer vision library. Okay, so there what do you need to do? You need to do some basic OpenCV functions like how to read an image, how to write an image. So write an image means you have done certain processing and now you have an image that is saved in a variable. Let's say image img is a variable. So after that you will use cv2.imwrite. Okay, so that is how you imwrite, imwrite. Okay, m here. Okay, imwrite, and let's say image, and you also give the name. Okay, file name. So this is how you do it. Okay, so you do that, then you do basic color changes. For example, you from RGB, that is red, green, blue, to gray and vice versa. So this basically is going to help you in the domain of data augmentation. Okay, so when you will do, let's say, CNN and other things, you would do data augmentation. Okay, so there you would want to change the like say the scale of the image, and you want to center crop, or you want to, let's say, center crop, or you want to, let's say, you also want to, let's say, left shift and right shift, and then sometimes you also want to do sometimes these affine transformations, very very important. Okay, means you want to, let's say, shear up the image a little bit. Basically you want to create artificial, you want to artificially increase the size of the data set to reduce overfitting. So very important, huh? This one, and color, this simple color changes and all. And the last but not the least, the most important part in this entire thing, if you are not so much in deep learning but in machine learning, you need to figure out a way to do feature extraction. Because for a machine learning, let's say you are doing logistic regression. Okay, logistic regression, what are you going to give into the model? You're going to give in data. What is this data? This is features. So in order to work on this, you should know actually how to extract features, right? So this is the most important step, okay, in the entire machine learning. In deep learning we don't do feature extraction because deep learning models are so strong and capable that they are able to, you feed here raw data, raw images, whatever raw images, and they can it by itself figure out the features. However, in machine learning, in this case, this is not true, and that's why you need to focus on feature extraction. And how? Then you are going to use hog and sift features. You have a function in skimage which will come in the next slide. In skimage you can find out hog features, and sift features can be found out in cv2 as well. Now what I don't want you to focus in this here, you are not doing image processing. Okay, you are doing OpenCV but you are not going into image processing, because OpenCV is mostly used for image processing. Okay, you are not going to do that, which means you are not going to do things like edge detection, you are not going to do things like line detection, and there are others as well, let's say connected components, or there are many things. Okay, so we are not going to do that. So you have to focus only on, let's say, this one and the fourth one, third one also you can say, but it will give you a good understanding in augmentation. That's why I have written it over here. Okay, so I hope this is clear. Once that is done, you will enter into machine learning. You will not directly go to deep learning, you will do machine learning, ML. So how you will do that? You will use this for, let's say, creating a simple logistic regression classification. So you will use an sklearn, you will use the library called sklearn, and skimage, as I said, will be used for, let's say, your hog features, or even some basic image processing things that are needed for sklearn. Okay, so this is what you will do. You will focus on this. I will make a video on this entire section too. Okay, after this is done, now is the time you will enter into neural networks, but you will not directly go for image neural networks. You will take the simplest MNIST data set. Okay, and then you will have a neural network, let's say a basic neural network, simple neural network. Okay, over here you can see. So let's say we have a simple neural network, and finally you have since MNIST has 10, or to say 0 to 9 digits, you will have 10 neurons in the last layer. All of them will be connected, and you will do simple image classification. This is the most basic in deep learning. Okay, image classification. So you are basically given images. Okay, you are basically given images, and then you are asked to find to which class the image belongs. Okay, simple neural network with cross entropy loss. So this is what you are going to do as your third step. Now what is going to be the fourth step? You are going to implement a simple convolutional neural network. So first we implemented a neural network, now we are going to focus on a convolutional neural network, and we will stick with the MNIST dataset. But if let's say you are comfortable with the MNIST dataset in the last step, you can also go for CIFAR 10 mostly, or if you have some compute power, you can also go for CIFAR 100. Okay, but CIFAR 10 will be just good enough, right? Let's say you're also done with that. After that, in the fourth or in the fifth step, you will do object detection. Why? Because after image classification using a CNN, so let's say this is your model. Okay, I'm just representing the model. Classification was taking this model and then having some neurons at the end for classification. This was classification. Here you will have another batch of, let's say, predicting some some values, and this will be used for what to say, as your bounding box coordinates. Okay, so this is basically object detection. This is classification plus localization. Okay, so this part is location, whatever. So this is classification. Okay, and this part, the bounding box part, is localization. So this is essentially your object detection. So once you are done with that, so here you will have your basic algorithms, let's say, RCNN, and then faster RCNN, and all of those things. Okay, and you will also have your YOLOs over here. Okay, YOLO 9 I think is the latest. So you will have all that over here. After you're done with object detection, you will come straight to image segmentation. So here again there are instance segmentation, then there is a semantic segmentation. Okay, so basically you are going to have types of segmentation. There is one more which I don't remember right now, but I'll tell you later. So this is basically you're going to do after classification. Okay, so for this you will need something as a masked RCNN. Okay, so for segmentation, or you will also use UNet. Okay, so UNet will also be used in medical images, which we'll see in the next slide I think. But these are the things that you can do. You can also have a custom unit if you have your own data set and some good compute power. Okay, so this is your sixth step in computer vision, learning computer vision. In the seventh step, what you're going to do, you can take medical images. So this is actually medical images. Okay, medical images. So here you can also use UNet. Why? Because medical images is actually something that automatically becomes another subdomain inside. So if this is computer vision, it becomes this medical images, it becomes a subdomain in computer vision. That's why I have written it separately over here. Okay, medical images, you can get so many data. You can get pneumonia classification data is there, which is very, very famous. It was also what to say, your competition on Kaggle. So this is the data set you can start with. Otherwise, if you have some other data set, you can also start with that. Okay, once you're done with this, you are basically going to get into the best part, which you might also like, which is generative AI. But you're not going to directly start using diffusers, because this is the one that actually is your DALI and the other things are based on. You're going to first start with VAE. Now you can also start with autoencoder, but it's mostly like a simple neural network only, so I'm not focusing on that. You can start with VAE, variational autoencoder. After that you can go for normalizing flows, and once you are done with all that, only then you come to the best part, which is, this is also based on UNet. Okay, which you might have seen in to say the image segmentation part. So this is also based on UNet, so you should understand image segmentation before you come to diffusers. Okay, but the idea over here is to go to it finally, and don't worry, we will be doing this fine. Now there are some things that I did not go over here. There is also as OCR, but the problem with OCR here is you just have an API. Okay, you don't need any coding. If you just know Python, there is just one line of code, you pass in the image and you get the text. So there's nothing to much learn over here. Object tracking, if you are interested in it, do. Otherwise it's not that important. Pose estimation, again, not nothing very fancy. I know, you can basically do it if you know the above things. If you have covered from 1 to 8, all of these things are very very easy. Okay, but since these, let's say, in the next, you can also have image search engine. Okay, so something like a Google image search engine, something like a Google image search. Okay, so basically you will use, um, there are many ways. Okay, this is called CBIR, content based image and video retrieval. So content based image retrieval here. So you can do this also. This is basically used to make image search engines. But again, all of this are something, once you can also do all those face detection that people talk about. And you can also do things like age and gender classification and all those things. So there are so many things that can be done, but the first 8 over here that you see, this first 8 needs to be clear, and this is exactly how your roadmap. Now obviously if you do certain changes here, things will work, but what I'm saying is this is the best optimized way of doing it in increasing level of difficulty. Okay, last one is just miscellaneous, so it can be done even before, because this is just one line of code. But I would still suggest you that you go from 1 to 8. Okay, if you really like the video, please like and subscribe. Thank you very much, and bye.